behalf of the Vice Chancellor of Trinity University, and of course, distinguished member of the university community, especially member of the University Senate, and other distinguished members of the University Community of OLABISI and ONABANJO University. May I welcome you all to another round of edition of the Professorial Inaugural Lecture. This time around to be delivered by the current Director of Academic Planning, OLABISI and ONABANJO University. He is a professor of physical chemistry from the Department of Chemical Sciences, OLABISI and ONABANJO University. He's no other person than a distinguished professor, Professor BABARINDE. Please, can we give him a round of applause? Quickly, before the Vice Chancellor declares the program open, let me quickly recognize distinguished personality in their presence. Right before us here is distinguished Professor of Environmental and Analytical Chemistry, Professor Ogun. So can we give him a round of applause? We call him our distinguished Professor of Education, Sociology of Education, Professor Taiwo in our midst. Please give him a round of applause. We also have the Director of OLABISI and ONABANJO University Business School, Dr. Ilo in our midst. We equally have the Deputy Registrar in charge of Academic Planning in our midst, Mr. Abiola. Any procession into this hall, as soon as they come in, I will implore all of us here to rise and remain standing as we welcome the academic procession into the hall. Please let us rise for that. Thank you very much. Distinguished ladies and gentlemen, once again, let me welcome you to 113th Professorial Inaugural Lecture to be delivered by a distinguished Professor of Biophysical Chemistry from the Department of Clinical Sciences, Faculty of Science, OLABISI and ONABANJO University. The title of the lecture is The Molecule Within Us, Structure, Survival, and Society, to be delivered by the current Director of Academic Planning, Professor Najeem Adesola BABARINDE. Of course, the procession is already coming into the hall, which is being led by the Dean Student Affairs, Professor Rasaki Kolawole Otunaike. Can we give them a round of applause, please, as we welcome him here? We currently have the Acting Dean Faculty of Environmental Studies, Dr. Abiola. Next person to him is, let's give him a round of applause, please. As we mention their names, we give them a round of applause. It's followed by the Acting Dean Faculty of Engineering, Dr. Abiola. Followed by the Dean Faculty of Agricultural Management and Rural Development, Professor Diran Awotide. It's closely followed by the Dean Faculty of Arts, Professor Samson Dare. Next to Professor Dare is the Dean Faculty of Pharmacy, Professor Latif Kassim. It's followed by the Dean Faculty of Clinical Sciences, Professor Babatunde Ayuade. Next to him is the Dean Faculty of Science, Professor John Abidemi Laoye. Professor Laoye is closely followed by the Acting Dean Faculty of Law, Dr. Bade Akirimade. Dr. Akirimade is closely followed by the Dean Faculty of Education, Professor Yekini Ogutimeni. He is followed by the Dean Faculty of Social Sciences, Professor Ayodele Odunlami. Dean Faculty of Social Sciences is followed by the Dean Faculty of Administration and Management Sciences, Professor Muse Chulanke. Next to Professor Chulanke is the Acting Provost, College of Engineering and Environmental Studies, Dr. Bashir Odufua. Next to Professor Dr. Odufua is the Provost, College of Agricultural Sciences, Professor Adewale Onosanya. Professor Onosanya is followed by the Provost of Abiola College of Health Sciences, Professor Mrs. Musili Fetuga. It's followed by the Provost Postgraduate School, Professor Olusegun Adebayo Lawal. And of course, the University Bossa, Mr. Semi Makinde, FCA. Mr. Semi Makinde is followed by the Acting University Librarian, Dr. Mrs. Shuema Roque Adekunsi. And of course, the University Registrar and Secretary Council, Mr. Femi Ogunwomoju. Next to the registrar is the Deputy Vice Chancellor of Administration, Professor Charles Olufemi Adekoya. Next to him is the Deputy Vice Chancellor of Academic, Professor Olatundu Abosede Oderidi. And of course, the inaugural lecturer of today, currently the Director of Academic Planning, Professor Najeem Adesola BABARINDE. Is today made honor by our main Vice Chancellor, the distinguished intellectual, entrepreneur, and of course, a distinguished scholar of this great university, the Vice Chancellor, Professor Abiola. Please let's keep clapping as we take their seats. Please let's keep clapping. Thank you very much. Mr. Vice Chancellor, who today, please let's be seated. Mr. Vice Chancellor, who today is the chairman of today's professorial inaugural lecture, other distinguished personality at the high table, distinguished member of the audience, gentlemen of the press, ladies and gentlemen. I now have the pleasure to invite the registrar and the Secretary Council of OLABISI ONABANJO University, Mr. Femi Ogun, to please step forward and invite our Main Chancellor, Professor Abiola, to declare the 113th Professorial Inaugural Lecture open. Mr. Registrar.
May I now invite the Vice Chancellor to please declare this 113th Inaugural Lecture open. The Vice Chancellor, sir.
The principal officers of the university, the provosts, deans, professors here present, members of studies, other university community here present, the family of inaugural lecturers, P.Sc, and other distinguished members here present. On behalf of the Senate of this university, I hereby declare the inaugural lecture of today open.
Distinguished ladies and gentlemen, today's 113th Inaugural Lecture, titled The Molecules Within Us, Structures, Survival, and Society, will be delivered by Professor Najeem Abiola Adesola BABARINDE. May I now invite the Vice Chancellor to please introduce today's inaugural lecture. Professor BABARINDE, please stand and remain standing.
I have the singular honor to read the citation of Professor Najeem Abiola Adesola BABARINDE. Prof was born on the 6th of June 1963 at Ayetoro in Yewa North local government of Ogun State. He started his early education at the local authority school, Amore, Ogun State, in 1969. He was transferred to the Methodist Primary School, Ewu, Mafoluku, Lagos State, in 1974, where he completed his primary education. He gained admission to Ayetoro Community Grammar School, Ayetoro, in the year 1979 and completed his secondary school education in 1984. He was admitted to study industrial chemistry at Ogun State University in 1984. He won an award at the end of 200 level in 1985-1986 session for being the best student of industrial chemistry at the first convocation ceremony of Ogun State University in 1986. He graduated in 1988, winning several prizes. After the completion of the mandatory National Youth Service at Government Day Secondary School at Dusi, in Katsina State in 1989. He worked briefly as assistant sales representative of National Oil Limited before joining the services of Ogun State University on 1st January 1991 as a graduate assistant. He obtained master's and doctoral degrees in biophysical chemistry in 1993 and 2003 respectively from the Premier University of Ibadan, and he rose through the ranks to become a professor in the year 2016. Professor Adesola had his postdoctoral training at the Department of Public Health, Physics section, and the Department of Biochemistry and Molecular Biology, University of Parma in Italy, through the prestigious award of the Training and Research in Italian Laboratory Fellowship of the Abdul Salam International Center for Theoretical Physics, Trieste, Italy, sponsored by UNESCO in the year 2010. He undertook the Advanced Security course of the United Nations Department of Safety and Security in the year 2010 and was awarded Advanced Security in the field certificate. As a prolific writer and academic par excellence, Professor BABARINDE has over 70 articles published in reputable journals globally. In addition, he has several books in chemistry to his credit. He has also served as a reviewer to more than 40 journals. He also served as editor of Journal of Nigerian Society of Physical Sciences. He is an associate editor of ASU Journal of Science and editor of Advanced Journal of Chemistry Research. In recognition of resourcefulness, Professor BABARINDE has on several occasions been appointed to serve in various capacities within and outside the university. Within the university, he has served severally as head of the department, acting director of Students Industrial Work Experience Scheme, COS, director of Quality Assurance, and currently the director of academic planning, to mention of the few. Outside the shore of our university, this important scholar has served as visiting lecturer to the Redeemer University, National University of Education, and from Adesola Polytechnic, and National College of Education. He has also served as external examiner to the University of Ibadan, Abiola University, Ile-Ife, Federal University of Agriculture, Abeokuta, Babcock University, Ilesha, Amando, Nnamdi Azikiwe University, Enugu, Batra University, Kobatro, India, whichever way it is pronounced. In addition, he has served as assessor for Professor Akeda to the Federal University of Agriculture, Abeokuta, Funab, Federal University of Technology, Akure, Ladoke Akitola University of Technology, Lautech, Bowen University, National University of Education, National State University, Best University of Technology, Federal University of Bukari, and Olusegun Okagbue University of Science and Technology. Between 1991 and now, Professor BABARINDE has attended several major national and international scientific and professional seminars and conferences, at which he presented well-researched papers. In the process of this career, Professor BABARINDE has successfully supervised several undergraduates, 8 master's students, and 6 doctoral students. He has also won research grants at both local and international levels. Our inaugural lecturer is a fellow of many prestigious professional bodies, among which are the Australian Institute of High Energy Materials, Australia, the Institute of Chartered Chemists of Nigeria, AGO-IWOYE. He is also a member of the American Chemical Society of Nigeria, Science Association of Nigeria, ResearchGate Scientific Network, and of course, the Italian Physical Society, Italy. Ogun scholar, he has 1,284 citations. With H index of 18 and I-10 index of 25. Excellent. In every assignment, Professor BABARINDE has consistently demonstrated principle, passion, confidence, commitment, accountability, and of course, good leadership. Professor Najeem Abiola Adesola BABARINDE is married to his heartthrob, Dr. Mrs. Abigail O. BABARINDE. And their marriage is blessed with 3 children and grandchildren. Ladies and gentlemen, please join me in inviting Prof to the podium to give his inaugural lecture.
The Vice Chancellor, the Deputy Vice Chancellors, the Registrar, Librarian, the Bursar, Provosts and Deans, Professors and Heads of Department, the Royal Highness, Spiritual Fathers and Mothers, distinguished ladies and gentlemen, greatest warriors. I stand here today by the grace of God to present this 113th Inaugural Lecture of OLABISI ONABANJO University, who is the third in the Department of Chemical Sciences and the first in the Physical Chemistry Unit, titled The Molecules Within Us, Structure, Survival, and the Society. Introduction. It is my foremost objective to make this inaugural lecture as explicit as possible, since I know that chemistry is not just only a science subject, but it's also a language, and it takes understanding the language to comprehend the subject. Secondly, an inaugural lecture is one major forum for town and gown to interact. Therefore, it is very necessary to ensure that we are all on the same page. A colleague attended an inaugural lecture, even right in this hall, in year 2021, and commented at the end of the lecture that he did not understand all that the inaugural lecturer said, whereas it was a stimulating lecture for those in the field. In Genesis chapter 2, verse 7, the Bible states that at the time of creation, the Lord God formed man out of the dust of the ground and breathed into his nostrils the breath of life, and man became a living soul. That accounts for the reason why the chemical elements found in the earth are also found in humans. Well, all chemical bodies, from plants, animals to humans, everyone is composed of several elements and molecules or compounds. And virtually everything we do in life involves chemistry. Life itself is sustained by chemical reactions, be it sight, as we see me now, breathing, digestion, or reproduction. The functioning of every organ of the body involves chemical reaction. Even water that serves as a medium for the various chemical reactions in the body performs the role because of its structure, which makes it polar. The functioning of the brain that controls the entire body of any animal or man involves chemical reactions. Any alteration to the original chemical constituent of any biological body affects the functioning of the body. The adaptation of biological bodies to the environment basically has a chemical undertone and can be explained chemically at the molecular level. We are all made up of molecules. The most common example is in living thing is water, like I've said, which constitutes about 55 to 60% of the weight of the human body. It serves as the medium for all reactions taking place in the biological system. It's able to play this role because of its polarity occasioned by its structure. It would have been a different story entirely if the water molecule were linear and hence non-polar. In fact, if the water molecules in us presently should suddenly become linear and consequently turn non-polar, we shall all be gone. This demonstrates that the structures of the molecules within us determine our survival as living beings. So, for every molecule in every form of material perform its role because of its structure. That is, each molecule has been structurally designed to play a particular role or roles. Definitely, for every design, there's a designer. Therefore, no matter the nature of a material, there is a God factor, the designer. It will interest everyone to know the underlisted chemically controlled biological phenomena. I'm talking about structure-function relationships in living organism. In each case, the molecule performs its role because of its structure. Consequently, the survival of each organism depends on the structure of the biological molecule within it. Number one, chemistry of vision. Rhodopsin is a protein that is essential for vision, especially in dim light. It is a combination of a protein called opsin and a highly conjugated aldehyde, 11,6-retinal. The photoreceptors in the retina that contain rhodopsin are rods. Each rhodopsin molecule in the photoreceptors is attached to 11,6-retinal. The latter becomes excited by a photon of light and isomerizes to the all-trans conformation. This excitation activates rhodopsin and leads to the depolarization of neurons. This depolarization causes an image to be transmitted to the brain. So that's a structural rearrangement. So that is what's responsible for our ability to sight, to see as individuals. Number two, chemistry of adaptation of crocodile underwater used in preying. I'm sure we have heard about crocodile at one time or the other. A crocodile succeeds in drowning even far bigger animals like the elephant just because of the chemistry of hemoglobin in his blood. Studies have now shown that this ability depends on a tiny fragment of the animal's hemoglobin, the protein that carries oxygen from the lungs to the rest of the body. The crocodile hemoglobin undergoes a chemical reaction that does not take place in the hemoglobin of its prey. The crocodile uses a waste product of metabolism, the bicarbonate ions, formed when the carbon dioxide dissolves in water, as the trigger for hemoglobin to unload the oxygen it carries. The more energy the crocodile cells burn up, the more carbon dioxide they produce. So, the bicarbonate triggering mechanism ensures that large quantities of oxygen are supplied only to the hard-working tissues that need it the most, thus conserving a submerged crocodile's limited supply, according to that reaction there. Now, please permit me to show a video of what happens, how a crocodile attacks elephants.
It's elephant versus crocodile. Here we see a mother elephant drinking water without any care that there could be predators nearby. The crocodile seizes the moment and bites the trunk of the careless mother elephant. It is very rare for a crocodile to attack an elephant. In a story by Jungle Book author Rudyard Kipling titled The Elephant's Child.
That battle would have cost the elephant his life, if not because it was mightier than the crocodile. You know, and crocodile, as small as it is compared to elephant, is able to do that just because of the molecule within. There's power in the blood. Third, chemistry of adaptation of birds to great height. The ability of some birds to fly to great heights, while other birds cannot, has to do with the chemical composition of their hemoglobins, which other birds do not have. The Greenland goose lives in the Indian plains all year round. The boar-headed goose lives at the high altitude Siberian lakes region and migrates across the Himalayas during the winter in India. The Andean goose lives in the high Andes all year round. Possession of a hemoglobin with high oxygen affinity helps to adapt boar-headed and Andean goose to high altitude. The amino acid sequences of the high altitude boar-headed goose and the low altitude grey goose hemoglobins differ by 4 amino acid substitutions. Only one of these substitutions is unique among bird hemoglobin sequences, that is, the mutation of at position 119 on the beta chain from proline to alanine. The Nobel laureate Max Perus has proposed that the 2 carbon gap left by this substitution at the alpha-1 beta-1 contact raises the oxygen affinity because it relaxes the tension in the deoxy or T structure. It was later found that the hemoglobin of the high altitude Andean goose has a gap in the same alpha-1 beta-1 contact region due to the complementary substitution at position 55 in the beta chain of leucine to serine. This similarity raises its oxygen affinity. Number 4, chemistry of snake poison. 2 groups of venomous snakes are particularly well known, vipers and elapids. Broadly speaking, the venoms in these 2 groups, which are chemicals, do different things to a victim. Vipers have venoms that are generally hematoxic. That means that venoms attack the circulatory system. They can cause bleeding or interfere with the ability of the blood to clot. Many famously venomous snakes, such as cobras, have venoms that are typically neurotoxic. This means that such venoms, which are chemicals, interfere with the transmission of nerve impulses. Such interference generally has an immobilizing effect, either making a victim's body turn rigid or lame. Number 5, chemistry of opioid peptide that modulates the perception of pain. We have a pentapeptide made up of 5 amino acids. One on the left-hand side. On the right-hand side, we have the mirror image. 5 amino acids are connected together. Now, the way they connect, if you reverse the order in which they are connected, that particular pentapeptide loses its property. Is a kind of peptide that helps to observe pain. But once we change the structure, that thing loses its property. Number 6. Chemistry of sickle cell disease or genotype. In sickle cell anemia, the mutation in hemoglobin principally affects the quaternary structure of hemoglobin and its solubility, but not its ability to bind oxygen. The difference between the hemoglobin of a normal person, which we call HbA, hemoglobin A, adult, and that of a sickler, HbS, is caused by difference in the amino acid at the point on each of the 2 beta shades. Out of the 574 amino acid residue that make up human hemoglobin, 2 glutamic acid residue, just 2 out of 574, are now replaced with valine. That is what is responsible for sickle cell disease. You can see how small things have great consequences. So the structures are compared there, glutamic acid, valine. Just the small difference in structure affect the property. And whatever anybody has suffered today as a result of sickle cell anemia, this is what's responsible. As a result, the hemoglobin mutation is responsible for sickle cell anemia due to reduced surface area caused by sickle cell shape, which has caused humanity, especially in Africa, fortunes and preventable deaths. These losses are avoidable if we do not take things for granted. Therefore, every bachelor or spinster should always remember that the nature of his or hemoglobin molecule can affect his or her marriage and the children that are born as a consequence of the marriage. The implication of genotype combinations are given there. AA and AA, very excellent. A and AS, good. And AA and SS, fair. AS and AS, bad. LS and SS, very bad. SS and SS, extremely bad. The story continues like that. A study in Nigeria has shown that Nigeria has been termed the epicenter of sickle cell disease globally. Sickle cell disease poses significant challenges to global health. It contributes significantly to the morbidity and mortality in the pediatric and adult populations. In the African continent, it accounts for 20% of neonatal mortality and 5% of the mortality of children under the age of 5. In Nigeria, about 50 to 80% of the estimated 150,000 infants born yearly with sickle cell disease die before they attain the age of 5 years. Those that manage to survive suffer organ-terminating damages, including stroke, which shorten their lifespan. There's a high physical, emotional, and psychological burden on the sickle cell patient. Someone living with sickle cell disease constantly oscillate between intense pain and small doses of healthy life. Number 7, chemistry of the feeding of fetus during pregnancy. We have all been in our mother's womb before. How do we survive inside the womb? For a mother to deliver oxygen to a fetus, it is necessary for the fetal hemoglobin to extract oxygen from the maternal oxygenated hemoglobin across the placenta. The higher oxygen affinity required for fetal hemoglobin is achieved by replacing the maternal beta subunit with the gamma subunit in fetal hemoglobin. As the gamma subunit has fair positive charges than the adult beta subunit, 2,3 PG is less electrostatically bound to fetal hemoglobin compared to adult hemoglobin. This lower affinity allows for adult hemoglobin to readily transfer its oxygen to the fetal bloodstream, a parent hemoglobin called fetal hemoglobin. These examples and many more illustrate the roles of chemistry in life. Oh, what on earth is not chemistry? Mr. Pastor, sir. Having laid the foundation of structure-function relationships in biological molecules, the next leg of the lecture will be to look at macromolecules in general and proteins in particular. Biological macromolecules are big molecules that are built from smaller molecules called monomers. They have very high molecular masses. They are essential for the maintenance of life in living organisms through the different functions they perform. As a result of their structures, proteins form a very important class of macromolecules, then proteins and their roles. Proteins are biological molecules built of monomer units called amino acids. They consist mainly of carbon, oxygen, hydrogen, and nitrogen. They are large biological molecules, usually having molecular weights higher than 5,000 Daltons. They have the following characteristics with the corresponding lesson to teach us. Lessons from biological molecules. 1. They vary in size, length, structure, ranging from small molecular weight peptides to polymers with very large molecular weight. The lesson this teaches us is that no matter the differences in our individual sizes and lives, each of us is called out for a purpose in our systems at the family, national, and global level. 2. They are involved in numerous biochemical roles in living organisms. They contain a wide range of functional groups which combine in various sequences, thereby forming a broad spectrum of protein functions. The lesson this teaches us is that there is a strength in diversity. None of us is exactly like any other in the world, yet we can all function to make our society, especially a multi-ethnic nation like Nigeria, run properly. Number 3, the proteins can act synergistically to perform roles that cannot be performed by the individual component proteins. Some proteins are quite rigid, while others display a certain level of flexibility. The rigid ones can function as a structural element in the cytoskeleton or in connective tissues. The lesson this teaches us is that there is a power in unity, as painted in the words of Ellen Keller, quote and unquote, alone we can do so little, together we can do so much. Number 4, changes in protein structure can cause diseases that affect the ability of a protein to bind other molecules or carry out its function. Diseases can also be caused by conformational changes in proteins that affect their solubility and degradability. The lesson this teaches us is that we become dysfunctional when we change the design made by God, our designer. A very important protein in many animals and man is hemoglobin, which is responsible for the transportation of oxygen in the body. It is the protein that is of interest to me. The blood of every vertebrate contains red blood cells, white blood cells, and platelets. Hemoglobin constitutes more than 90% of the protein content of the red blood cell. Although the blood is considered as an essential transport medium in the body, it does not provide a suitable medium for oxygen transport, as it can transport only about 2% of the total oxygen needed for cellular activities. The remaining 98% of the total oxygen is carried by the hemoglobin molecule. Free hemoglobin has only a little capacity for oxygen transport. On the other hand, the oxygen transport ability of hemoglobin increases tremendously in vivo compared to when it is dissolved in the blood. Mammalian hemoglobin weighs about 68,000 daltons and comprises of 4 units, as we see there. Please permit me to show. This is hemoglobin, containing 574 amino acids. And this is where it oscillates between the oxy, when it's oxygenated, and when it's deoxygenated. And we have thousands and maybe millions of these in a drop of blood. Mr. Vice Chancellor, sir, the hemoglobin molecule is made up of 2 parts, heme and globin. According to this, it's a combination of 2 names. Hemoglobin subunit comprises the globin and the heme protects group. The hemoglobin molecule conveys oxygen from the gas exchange organs to body parts where it is needed and takes oxygen and CO2 back to be exhaled. Hemoglobin has attracted so much investigation because of the critical physiological functions it performs. Moreover, it replaces a range of behaviors that are very similar to those of many multi-subunit enzymes. It has therefore been intensely studied as a modern molecule in understanding how the arrangement of amino acid residues affect the functions of multimeric proteins. Hemoglobin loses its biological role as an oxygen carrier if the central bound iron 2 metal ion is oxidized to iron 3. We know it. When somebody has a cut and blood comes out, immediately it comes out, the color of the blood is red. But after some few minutes, it comes to brown. What happens there is that the iron there, iron 2, Fe2, changes from iron 2 to iron 3. The oxidation state changes. It's been oxidized. So that's why the thing becomes brown and it loses its function as an oxygen carrier. Now, the amino acids that we have, standard amino acids that we have in protein, there are 20 in number and they are classified according to their side chains. Number 1, non-polar aliphatic side chains. Number 2, aromatic side chains. Number 3, polar but uncharged side chains. Number 4, positive charged basic side chains. And then number 5, negatively charged acidic side chains. These are the 5 groups into which the amino acids that make up a protein are grouped. Now, let's look at the levels of structure. Since we are talking about structure, the levels of structure in protein. Taking hemoglobin as an example because it's the focus. It exhibits 4 levels of structure. Number 1 is the primary structure. Number 2 is the secondary structure. 3 is the tertiary structure. And number 4 is the quaternary structure, as illustrated. Now, the primary structure is the linear arrangement and connection of the various components of the amino acid that make up the protein. But in addition to this, there is a secondary structure where the molecule can exhibit additional structure. It can fold, turn into a coil, or it can lay one over the other. So these are different forms of secondary structure. Then also have the tertiary structure, in which a long chain is like you have a pipe, a long rope, and then you fold it, and then it becomes something smaller in length, but it's been folded. That's the tertiary structure. Then you have the quaternary structure. In the quaternary structure, we have 4 different chains, as shown in the diagram earlier shown to us. You see, 4 chains, they come together, and they're moving back and forth like this. Right from the day you are conceived to the day you die, that's how they continue to move. The day they stop working, that's the day we leave this world. Now, allosteric effectors. The protein, which is hemoglobin, is able to carry out its function of carrying oxygen because of some components in the blood system, in our body system, that relate with it. These are called allosteric effectors. So when they move near the hemoglobin, it makes the oxygen that is bound to release. Now, Mr. Vice Chancellor, sir, In 1960, Peru's unraveled the structure of human hemoglobin from the result of X-ray crystallography. The heme group in the tetramer are so far apart that a direct heme-heme interaction is not possible. The ligand binding sites in the subunit of hemoglobin, like many other multimeric proteins, can interact indirectly with other sites which are distinct and distant from them in same molecule. This is termed the allosteric effect. The allosteric effect is induced when an allosteric effector binds to the relevant protein. The hemoglobin molecule has its own allosteric effectors. These are mainly organic phosphates. The organic phosphates, there are different types of them, 2, 3, B, PG, and so on and so forth. Hemoglobins of birds, because I work much on birds, hemoglobin of birds. Hemoglobin also binds to organic phosphates, such as adenosine mono, bis, and triphosphate. The structure of some organic phosphates are shown in figure 16. We have different organic phosphates that regulate the binding of oxygen and the losing of oxygen for our use. Now, chemistry of the sulfhydryl group, Mr. Adesola, nearly all proteins contain sulfur in some form as part of the side chain of the amino acid building blocks. The two sulfur-containing alpha amino acid residues in proteins are cysteine and methionine. The thiosulfhydryl of SH side chain in cysteine is very reactive, whereas the thiol group in methionine is less reactive and is non-polar. Protein sulfhydryl groups have been implicated in numerous physiological functions in living organisms. The cysteine residue plays significant roles in the formation of the tertiary structure in proteins because of its ability to form inter and intra disulfide bond. Of the 20 common amino acids found in protein, cysteine is the only one whose side chain can form covalent network. Hemoglobin sulfhydryl group. Monitoring the reactivities of hemoglobin sulfhydryl groups has provided useful information on the mechanism of oxygenation. Riggs explored the role of sulfhydryl groups on the hemoglobin oxidation process. He discovered that hemoglobin sulfhydryl group influence the mechanism of heme-heme interaction in the oxygen binding process. Sulfhydryl groups in protein can be classified as reactive or unreactive. The accessibility of the cysteine residue located at position F93 beta depends on whether the hemoglobin molecule is liganded or not. In deoxy hemoglobin, this sulfhydryl group is protected by histidine HC3 146 beta, which forms a salt bridge with aspartate FG1 94 beta and lysine C5 40 alpha. The salt bridge so formed is broken in liganded hemoglobin. As a consequence of this break, histidine HC3 146 beta makes a 40% contribution to the alkaline bond effect of hemoglobin. Quantification of sulfhydryl groups in protein. Different methods are used to quantify the sulfhydryl groups in protein. They can use mercaptide, then we use alkylation method. We also use addition across a double bond. Then it can also be done using oxidation of sulfhydryl groups by aromatic disulfide. Mr. Adesola, the reaction profile for reaction of hemoglobin of these beds, as shown in the figure 23-24, show that the K apparent values are pH dependent. We try to monitor the reaction of hemoglobin across pH, and then we see the effect of pH on the reaction. Such profiles were analyzed in terms of the fractional population of the tau anion, form of the sulfhydryl group, and the effect of the salt bridge form in half-state hemoglobin between histidine AC3 1.6 beta and aspartate FG1 at 94 beta. This concentration led to the equation 1. This equation is used to analyze the profile that we have there. And we have the table 3 and table 4 giving us the parameters that are used to fit the plot. Well, my own contribution to knowledge in the field of biophysical chemistry. Mr. Chancellor, sir, I have been involved in research in the kinetics of reaction of DTMB with the sulfhydryl groups of hemoglobin, a protein that is responsible for oxygen transport in red blood cells. Much emphasis has been placed on the role of the quaternary structure transition in the oxygen binding process, which hardly any mention of a possible role for the tertiary structure transition. My research work has focused on reactive hemoglobins of different animals with tri-phi-diethylbenzene 2-nitrobenzoate DTMB in order to unravel or explain the possible role played by the tertiary structure transition in the physiological process. My first investigation was on the separation of the major and minor components of chicken hemolysis using chromatographic methods. This was followed by studying the kinetics of the reaction of chicken hemoglobin sulfhydryl groups with DTMB in the presence and absence of the allosteric effector in of P6. Basic kinetics was observed for the isolated major hemoglobin. This result was similar to what was observed for the whole hemolysis at low pH, indicating that the basic kinetics was not due to the fact that there were two components in the hemolysis, but rather is a property inherent in the chicken hemoglobin. Secondly, I've collaborated in the investigation of the effect of single point mutation in human hemoglobin from glutamic acid to bedine, as mentioned earlier, at position 836 beta of hemoglobin that distinguishes sickle cell hemoglobin HbS from normal hemoglobin HbA. We investigated the effect of this mutation on the reactivity of the cysteine F993 beta sulfhydryl group. Recall that HbS is responsible for the deadly sickle cell disease. HbS was expected to be more reactive towards DTMB due to the fact that it has a higher net positive charge than HbA. Contrary to expectation, it turned out that the reactivity of the sulfhydryl group of human hemoglobin A was faster than that of HbS. This result inspired us to be interested in what the reason of DTMB will be toward the reaction of DTMB will be towards HbC, which is known to have a greater net positive charge than both HbS and HbA. This is also special because the lysine replaces valine in HbS or glutamic acid in HbA. Therefore, we aim at comparing the effect of A3 beta glu-lysine mutation on the reactivity of cis F993 beta sulfhydryl group of human hemoglobin C with those of human HbS and HbA. Naturally, we expected that the rate of the reaction of DTMB with the 3 HbS and will be in the order of HbC, HbS, HbA. That is, in the order of their decreasing net positive charges. However, we found that this was not so, except that for the opponent derivative, HbC between pH 5.8 and 7.5. Our finding was that HbA reacts faster with DTMB and HBS. Arising from this, we expected that HBS will react faster than HBC. This turned out not to be the case. The major contribution of the study to knowledge is that the net charge on the hemoglobin does not play a specific role on the overall rate of reaction with DTMB. The charges that will be important will likely be those of the amino acid residue that are electrostatically linked to the cysteine F993 beta sulfhydryl group. Furthermore, an investigation on the structure-function relationship of the major amino components of the hemolysis was also carried out. The two components of drug hemolysis were separated using chromatographic method. The kinetics of the reaction of DTMB with each of the two hemoglobins were compared in order to further probe into the effect of the mutation between the two hemoglobins on the structure-function relationship. Out of the tens of other groups per hemoglobin tetramer seen in the amino acid sequence, via titration with p-hydroxybenzoic acid, detected only 6 reactive sulfhydryl groups. I also found that out of the 6 reactive sulfhydryl groups, only 4 were titratable with DTMB. A study of the kinetics of the DTMB reaction gave 2 kinetic phases that the fast and the slow. In each case, the apparent second order rate constant very strongly with pH. I also investigated the kinetics of reaction of DTMB with the major amino hemoglobins in the presence of inositol P6. I found out that inositol P6 reduced the rate of reaction for each of the 2 hemoglobins. In each case, quantitative analysis of the pH dependence profile of KLPP revealed that the reaction of cysteine F993 beta resulted in a pKa increase of 0.88 for the Ackermann derivative compared to the pKa's calculated for oxy and carbon monoxide derivative respectively. This indicates that the salt bridge formed between cysteine AC3, 146 beta and aspartate FG1 94 beta is more strengthened by inositol P6 in the Ackermann compared to the oxy and carbon monoxide derivative. My journey to the world of cancer research. During my postdoctoral research in Italy, I collaborated in investigation of the synergy action of potassium bicarbonate derivatives in the proliferation of HS578T cancer cell line that reduce the cell cycle. At a concentration of 5 millimole, K-derivatives is able to modify the tumorigenic potential of human breast cancer cell, interfering in vivo with the capacity of the HS578T cell line to migrate under chemotactic stimuli. Despite this, a KD solution does not exhibit any appreciable toxicity as confirmed by the proliferation assay. My journey to the world of bioremediation. The inaugural lecturer has investigated several biomasses for utilization in bioremediation of contaminated soil and water bodies. By means of sequestration, these materials are found to be far more economical than the conventional method used in treating industrial effluent. Conclusions and recommendations. Mr. Vice Chancellor, sir. Biological molecules play great roles in our lives because their structure determines the survival of all living things. This means that our survival depends on the structure of the constituent molecules that make up our bodies. As shown in the case of sickle cell anemia, the kind of society we find ourselves depends on the molecules we have. Nigeria has been labeled as the epicenter of sickle cell disease. This disease is partially responsible for our high infant mortality rate, in addition to the untold painful experiences and financial expenses on both the sicklers and their loved ones. If you do not want to continue to be left behind or spend huge amount of money to treat the sickle cell patient unnecessarily, as we must not leave anything to chance. There's a need for a decisive action at all levels of government to make our society free from the preventable societal problems such as SCD rather. By working together, we can bring an end to this disease and to the terrible statistics associated with it. Recommendation. Mr. Vice Chancellor Sam. Based on the above and the issues raised in this lecture, the following recommendations are made. 1. Government should make a premarital genotype compatibility test compulsory. A law should be enacted to make the premarital genotype compatibility test compulsory. Such genotype compatibility test will ensure that children suffering from sickle cell anemia are not even born at all. As the saying goes, prevention is better than cure. Why? Why live a life filled with pain when such pain can be avoided? The common saying, love is blind, is what has ruined many lives just because of ignorance or by neglect of simple knowledge they ought to have, especially in Nigeria. The Bible says, my people are destroyed for lack of knowledge. Hosea chapter 4 verse 6. The knowledge of genotype and the observance of rules will save many from premature death. It is important for those who want to go into marriage or any intimate relationship with the opposite partner to know their genotype before saying yes to that beautiful lady or to that handsome man with whom such wish to spend the rest of his or her life. A man once told me many years ago that the colossal amount of money he had spent to sustain his 22-year-old daughter then, who was a sickler, the man said painfully that the money was enough to build a 3-bedroom flat as of that time. Similarly, we need a national center for biotechnology information that will provide genetic sequence database and annotated collection of all publicly available sequences of deoxyribonucleic acid DNA, research in linkage with international bodies. The DNA test has proved so essential for the determination of paternity and maternity, especially when infidelity is suspected. It was reported online this year that the lady was adopted as a baby in 1966, that was adopted as a baby in 1966, had little information about her biological parents. After about 57 years, she searched for them with DNA tests, and she eventually identified her mother. Finally, they met face to face. After their first meeting, she continued to talk with her mom on phone, often asking questions she had wondered about all her life. Her mother provided the answers, and she needed to make sense of her existence. Apart from hemoglobin, another very important molecule within us is DNA, which is used in investigation of crime. A few years ago, it was reported online that a man was accused of raping a lady. He was arrested but refused to cooperate with the security agents to get his DNA to ascertain whether he committed the crime or not. He was given a bottle of drink. All effort to get sample from his body failed. So what did they do? They gave him a bottle of drink and put straw there. Definitely we have to drink, yes or yes. He drank it and with the straw and threw away the bottle and the straw. At the end of the day, he took the straw and got his saliva. From there, he got his DNA and he discovered that he actually committed the crime. Number 3, the government should continue to regulate the use of hard drugs because of its effects in the body. What hard drugs do is to alter the chemical reaction. That's why you see people that are on hard drugs, they misbehave, because these are chemicals that will interfere with the naturally arranged chemical reactions in their body. 4, there's the need to regulate the quality of food that are sold to the public, because sometimes food that you call food can eventually become poison, because some of them will react with the body, with the molecules in the body, and they end up becoming poison. And sometimes food will react with food. There are some food combinations that are not good. So this is a challenge. Number 5, I would like to use this medium to call on the government at all levels to ensure that professionalism is our watchword in all that we do. The sale of chemicals should be strictly regulated. Finally, to the general public, everyone needs a basic knowledge of chemistry. In our day-to-day activities, for example, there are many people who do not know that it's wrong to wear black dresses in hot weather. Because such a black clothes will serve as what we call black body in chemistry. It will absorb all the radiation coming from the outer space, and that is injurious to our body. Oh, what on earth is not chemistry? Acknowledgement. Mr. Vice Chancellor, sir. Firstly, I thank God for making this day a reality. I appreciate Him for His mercies that I've enjoyed from the time I was conceived to date. I thank the Vice Chancellor, Professor Abiola, and the other principal officers of the university for the opportunity to deliver this inaugural lecture and for the efforts in creating a conducive academic environment. I would also like to thank all the past Vice Chancellors and their respective management teams for all their efforts in taking this university to the enviable heights it has reached. I'm indebted to the following individuals and organizations for the support, guidance, grant, and fellowship that I've received over the years to support my career in the academia. The International Center for Theoretical Physics, ICTP, United Nations Education Scientific UNESCO, University of Parma, Redeemers University, National University of Education, Foundation Casade, the PASMO, the PARMA, for the research grants granted to my host in Italy. I want to thank late Professor Ida Otali and late Professor Giuseppe Pinsi. These people have really contributed in saving my life. Professor Simonetta Crossi, Professor Stefano Bettati, Paulo Delabati, and Fernandez Erasmus. Dr. Francisca Pusi, Dr. Luca Bruni, and Dr. Bright Nwaro. In a special way, I must acknowledge my spiritual role model, Pastor Dr. William Folorenshaw Kumoyi, the General Superintendent of the Tipa Christian Life Ministry, and my academic role model, Professor Kende Omocheyi Okonjo and his wife, Mrs. Chinwe Adigwe. In the same vein, I sincerely thank and appreciate all my academic mentors and teachers, Professor Layo Odukoya, late Professor S. Obashesan OAU, Professor A.A. Adeleke UI, Professor D. Alabi, Dr. Andrew A. Dimenyin, and Mr. Kinyaderomu. My appreciation also goes to my colleagues, Professor Jonathan Oyebanji, Babalola, the President, Vice Chancellor of Ogun University in Iwo, who I call a friend indeed, a friend of David. Dr. Sarah Nwozo, Dr. Adesola Frodeke, another course mate. In fact, my secondary school classmates, are you there? Yeah. Can you rise for the recognition? Thank you for coming. Please have your seats. We left secondary school in 1984. I met one of them after 1984 today. Since 1984. But we've been interacting on WhatsApp. So then that secondary school, in the university, my colleagues at OU here, and my colleagues in UI, where I did my master's. And today I have in our midst Dr. Alima Alabi. Can you rise up for recognition, please? Dr. Alima Alabi, thank you so much. She is the coordinator of my set that entered UI in 1991 and finished in 1993 for master's. And we've been together. So another classmate at the undergraduate and postgraduate level, for the challenges and encouragement I've received from each of them, I cannot but thank all my past and present undergraduate, postgraduate, and doctoral students. You have all greatly inspired me. I cannot forget the moral and spiritual support I've received from Sophia and Mrs. Solomon AGO-IWOYE, my senior partner. Likewise, I thank Professor A.V. Jibo Bigmomi, Professor M.O. Efuntoye, S.O. Olatunji Elijah, R.A. Abibola, Dr. J.S. Ashidi. They have been my companions in the journey to the promised land. I especially thank Professor John A. Laoye, our present dean in science, and all the past deans, as well as all the staff members of the Faculty of Science. In particular, I appreciate Professor B.M. Ogun, Dr. O. Adeyemi, Dr. A. Ibikunle, Olubomeyin, Oshobamiro, Otewolora Ojule, Ogunmoye, Sanyaolu, Ogundare, Oladipo, Yusuf, Adeleke, Ashimi, Mr. Ogulaja, Mr. Ogulade, Mr. Ogunbanjo, Mr. Adekoke, Oshulego, Oshinudu, Ojaoba, and Olorunle of the family of chemical sciences. My sincere appreciation goes to my pastors and spiritual mentors with their spouses. Pastor A.O. Araromi is Pastor Aransa. Okay, all right. Pastor E.P. Roshilu, I wouldn't know if he's around. Pastor S.B. Adedipe, Pastor J. Idris Awomate, Pastor Ogunkwile, Pastor Adeyegbe, Pastor Laifa, Pastor Laifa, please kindly rise for recognition, sir, to the permission of the Vice Chancellor. Thank you for coming, sir. Pastor Yewale, Pastor Olamide, if any of you is around, please kindly let me know. Pastor M.Sc, and all the regional overseers of Deeper Christian Life Ministry in Ogun State, for their pastoral roles in molding my life spiritually. In particular, all members of the Deeper Life Bible Church in the Jebugo region are greatly appreciated for the nuggets of spiritual blessings received. I especially thank Papa and Mama, Agbelusi, Pastors Marcos Adini, Tunde Yusuf, Taiwo Onabanjo, Karade, Sanyaolu, Michael Aleyo, Shola Olumide, Musa Dekwite, Olayemi Shuyemi, for the all-round support I've received from you. I quite appreciate my in-laws and their spouses, Professor J. Olowo Kere, Deaconess Iwa Agbeja, Apostle T. Agbeja, Overseers J. Agbeja, T. Agbeja, Apostle Agbeja, Pastor Shola Olumide, and Pastor J. O. Oyewale, who is my son-in-law. I also appreciate my uncle, late Chief Ebenezer A. Odunfa, my cousins, especially Chief Akambi Babarinde, and late Madam Alice Ajayi. She's late now, but I understand she's absented here by the son, Dr. Ajayi. Then my aunt, Mrs. Aina Jimo, and my siblings, late Madam J. Oguwa, Mr. Tatiti Babarinde, my brother, Mrs. Kubra Hussein, Mrs. Fatima Atosho, and their spouses for the moral support I've received from them over the years. The unquantifiable roles played by my late parents of blessed memory, B.T. Babarinde and Madam T. Babarinde, in educating me is highly appreciated. Finally, I'm greatly indebted to my wife, Dr. Mrs. Abiola Babarinde, and our children, Darius, Grace, and Glory, for your preaching and uncommon support I've enjoyed from them. I deeply appreciate and especially thank all the people who have contributed to my life, but are too numerous to mention, for the roles they have played in my life. May God reward you all bountifully. Mr. Panchel, ladies and gentlemen, I thank you all for listening, and God bless.
Destiny, I have waited patiently. I have vision, though I believe. I know I can count on me. So stand up for the champions, for the champions. Stand up, stand up, stand up.
You may have your seats, distinguished ladies and gentlemen. On behalf of the Vice Chancellor, Senate, and management, students of the OLABISI University, I want to sincerely thank you all for attending this 113th Inaugural Lecture. We wish you safe journeys back to your respective abodes. We thank you very much for coming. And the inaugural lecturer also, I will reiterate his thanks to all of you. You are all important and we appreciate your attending this event. Kabisi, Alaye, Ofaito, Atwekpolo, Eshitewa, thank you very much for coming. The representative of the Inuawe is also here with us. He's one of our own, a retired professor from the Department of Nigerian Languages and Literatures, Otumba Oshogo Chelsea. Professor Shola Adesola, we're glad to have you again in our midst. Thank you for shortly. We will declare it closed. May I implore you to please stand and remain standing while the procession is exiting in reverse order. Please let's maintain this order. Finally, the Vice Chancellor, sir, please declare this 113th Inaugural Lecture closed.
It has been interesting indeed, but there's one thing I had to my lexicon today. Please, the village, please open a chemistry laboratory beside your kitchen, so that when you combine the food for us, we will not react and alter the molecule. We don't want to die yet. So please, always do that for us. Even if that is only what we can take away from here today, is enough. Again, I also had another one. They said we should be testing our genotype before love blind their eyes. Well, that's theoretical. If somebody has been kissing, and then say go and check genotype, that will not listen to you. So maybe what we do is that we also open another chemistry lab beside the rooms. Before you start kissing, check your genotype there. The prison officers of the university, provost, deans, members of Senate here present, other members of the university community, B.Scs, the families of the inaugural lecturers and all other people that have come to witness this occasion. We thank you all on behalf of Senate of this university. I hereby declare this inaugural lecture closed.
Can we please stand and remain standing? While the session is exiting in reverse order, the wife of the inaugural lecturer should please join us immediately for a good photograph outside. Thank you. Once again, we thank you very much for coming.
Thank you very much. We now join the procession to exit the hall. Thank you. Journey messages back to your various destinations.
Thank you.